Welcome to our session in management theory and practice. I must also make mention that this is a sub-component of project management. And because you are managers, this component was brought in. Managing people, managing events, managing projects. So it is a sub-component, just a sub-component that you as a manager will need to know. So we're going to look at what is called PET and what is called CPM. PET is simply a project management tool, which is often used to calculate the amount of time usually that would take to realistically finish a project. We usually use charts to explain the tasks. We usually use a Gantt chart to explain the tasks. So to start with, a project really has interrelated set of activities which have a starting point and a unique ending point. And so these will cut across lines and they need to be varied by the different kinds of skills and professions that will be imbued in it. So when a project is being done, for instance, to construct a house, you will need to plan the duration of time that you expect it to be done. And so this planning will require materials, it will require assembly. The whole essence is to ensure that you reach a completion point where this project is finally executed. And as such, we use this component of project management as well as management theory in practice. So project planning may be used for so many things. If you want to plan for the construction of a plant, if you also want to plan a wedding, for those of you who would want to be wedding planners, you could use this. Those of you who design computer systems, this is very widely used. So it is used by a variety of specialists. It is a very simple logic framework that interrelates certain projects that will be scheduled in a way that one activity will precede the other. So I'm not going into details on explaining what a program is, what each of these ones are, but I'll definitely dominate on three key things: how to come up with network diagrams, how to come up with what is called the critical path analysis, and also how to evaluate the costs estimates. So we're going to use what we call the PET analysis, which is the program evaluation and review technique. And we're also going to look at what is called the CPM, which is a critical path model. So to start with, since we're going to look at what we call networks, what is a network? In this case, we'll be defining a network. We'll be looking at a graphical diagram which has certain configurations. We're going to look at two kinds of diagrams. One is called arrow on arrow. The other one is called arrow on node. So these are the two diagrams that we're going to look at. So in this instance here, if I could briefly zoom in, it is just epitomizing a project that looks at a software design. So there are certain programs that can precede the other. So this is simply a framework that you need to design. After this, we go to this. After this, there are two events that will come, or three events that will come. Upon which they are completed, another event will come in. So these are the networks that we want to understand. So now the initial stages or step that is involved in the PET or CPM project scheduling will be determining the specific activities that make up a project and how they're related to each other. And so an example will be such. I'll look at this example, then we'll go to our assignment. So we have activities that are outlined as A, B, C, D, E, and F. So there's a description of activities here. Number one, we are going to do the budgeting. And the budgeting is one activity that does not have a immediate predecessor. Means there's no activity that comes before budgeting. So you assume that you're going to take 2 weeks to budget that. Then the second activity, we'll name it as B, will be obtaining what? A machine. So you predict that machine B will come after the budgeting has been done. So you do B after A. Then the next part will be to hire an operator of this very machine. So you can only hire one operator and find the operator within a week, just after you are done with what? With obtaining a machine. Not only that, you're going to install the machine. That will be activity D. So activity B is obtaining what? The machine. This will be after we have what? Made a budget. Then activity C will come, which will be hiring an operator, after which we have done what? We have made a budget, not buying a machine. This one is coming from the same event. Soon after we made a budget, we'll do two things. Number one, we'll do what? We'll buy a machine. Number two, we will hire an operator. Then we'll go to installation of the machine, which is activity D. Now this will take only 1 week, but will only happen by the same operator will be hired. So it will only happen after we hire the operator. Then the activity which follows is training the operator. We can only train the operator after activity C is done. So this activity C is hiring the operator who we train thereafter. So E comes after C. So I will want you to take this as an after activity. Then finally, we're going to produce what? The goods. The production of the goods will happen after two events have happened, D and E. These events will be installing the machine and also training the operator. Now these activities can be illustrated by what we call a network. So we're going to use the following terms: activity, which is simply an effort that is required to complete the task. It will be represented by the arrow. Then we're going to use a node, which is actually the beginning or the completion of an activity. It will be denoted by this or that. Then the rules that are involved whenever we're constructing a network are: number one, we need to ensure that each activity is defined by one. Each activity represented by one and one arrow only. The second one is that before an activity can be undertaken, all the activity preceding it must be completed. So you cannot do one without the other. And the other rule is that the arrows that are depicting the various activities must be indicative of a logic procedure only. So the length and the bearing of the arrows are of no significance, but it is important that they should have a logical procedure. The fourth consideration is that the direction of the arrow will indicate the general progression. This entails that one, the head events and the tail events, there's one which precedes the other. So this arrow is very important because it shows where it's coming from. Then number 5 is that the number of activities terminate at one point. The number of activities will terminate at one event. It indicates that there's no activity that is emanating from that event. So this simply means that once an activity ends on that, there's no other activity that will emanate from it. Then also the events are identified by numbers. You can use numbers or letters. Then also the activities are identified by their starting and ending events or by alphabets. So this can be replaced by the other. Then also we need to understand that a network should only have one initial terminal. It should only emanate from one. All right. So this one should only have one initial and terminal node as follows. So this one is coming, this arrow has where it's coming from, this arrow has where it's coming from, or vice versa. This one is there, but B is coming from A, C is coming from this node here. So this is called a merge event, where two events will form one. And this is called a burst event, where two events will emanate from one node. So a network should only have one initial node or one terminal node. Then also the parallel activities between the two events without intervening events should be prohibited. So there's no crisscrossing. Okay. So also there are dummy activities that should not consume any of the time and resources. So an efficient network usually will contain a minimum number of dummy activities. So dummy activities really activities that will not consume any of the time. We usually use dots. They're required usually to portray the correct procedure of the relationship. Then looping is not what? Allowed. Don't crisscross. So just a quick emblem. We're talking about an arrow symbolizing what? An activity. Then this dot is an event. Then if you have this, we simply mean that the activity must be completed before the other is completed. So if we're talking about activity A must be completed, then comes B, then comes C. And this one here simply means that activities A and B can occur concurrently. Activity A and B can occur concurrently before C comes, and D will come soon after C is done. And this one is where activities A and B are completed before activities C and D begin. Okay, but also it is a little bit complex here because activity C can begin independent of D. So activities C can begin independent of D and vice versa. So we're going to look at a simple network diagram here, which shows the start point and the projection. So this means that our paths from the start to the end will have the following routes. We can move from the start. This is A, B, C, okay, then end. Then we can also start from here, the start, B, D, B, C, end. We can also start from here, the start, we go to D, E, F, and N. So we have three paths that are distinctive. 1, 2, and 3. So when
not four, not four, Mr. Collins, not 4 or 5.
Okay, let's identify them. We said we have what?
We have start, A, B, C, then end.
And end, okay.
Yeah, the other one is start, A, B, E, F,
then end. Okay.
yes.
Then
the other one is start, D, B, C, end.
Then we have
the other one is start, D, E, F, C,
E, F, C,
C, then end.
Where?
Then the other one, the last one is start, D, E, F, end. F end.
Yeah, so these are how many routes we have? 1, 2, 3, 4, 5. Actually 5, you're right. Okay, so these are the various routes that will be taken. So now I want us to see the different ways in which this project can be done. Okay, so these are just the different routes that we are looking at. The idea is to understand how the paths that we have are. Then we have this, which is called a dummy, usually in a dot. It means it does not require a lot of time. Okay, it's a dummy variable. So our critical path model usually aims at determining the time it takes to complete a project, and it's important because the activities on which the manager has to focus on will be strictly amongst the available options. So I want us to construct an activity from the given variables before we go to these formulas. So if we go to our assignment here, okay, we go to our assignment here without looking at these figures there. So we have the following activities. Okay, we have A here, B, C, D up to J. Then we have the preceding events. We have A, B. I wish I could just, let me just crop this so I could just learn how to draw the diagrams. Yes, before we look at how to evaluate the critical path. Whilst I'm doing that, can anyone ask a question at this point?
Okay. On these figures that we have found here, like these decimals, is it okay to round it off, maybe like 2.05? Isn't it okay just to say 2.1?
No, time is a continuous variable. So rounding off deprives of even a second and a minute that could be important in completing a task. So in your assignment, if you're going to take a look at it, you'll discover that even the actual figure that he used, although they had decimals, they were also rounded off to some extent. All right. So here is the network that I want us to draw. So I just want you to, with what we've talked about so far, understand how the formulation will be done. So how do we draw the network here? So we have the events here that are illustrated A, B, C, D, up to what? J. And here we're having the preceding events that we now need to illustrate. Okay, so we can start as follows. So I said there are two methods that you can use whenever you're doing our network. Can somebody remember? What are the two methods that I said?
Arrow on arrow.
Arrow on arrow, yes.
And arrow on node.
And arrow on node. Okay. So we can use these letters now. We can use arrow on arrow. Then later on, we can look at arrow on node. So we just want to see how the projection of this. So our starting event here is what? A. Okay. So what event comes after A? After A, what event comes?
B.
B.
And C.
What other event comes after A? C. Okay. So after B, what comes?
D.
And after B, what else comes?
E.
So after B, we have two events which are happening concurrently. We have B, C. So there's D and what? And E.
And E.
All right. So these ones are coming after event B. So we're going to put here. After B, we have D. After B, we have what? E. Okay. What other event comes? After C, we have what?
F.
F. So put our F there. Get there. All right. So far, are we together?
Yes, sir.
Then we're also told that after D, what comes?
G.
So there's D. After D, we have what? A G. So G there. Okay. So after D, we have G. Then after E, F, and G, where's E, F, and G? E, F, and G, these ones, or what comes?
H.
H. So after E, F, and G, all of them are pointing to one event. What kind of event is this according to our notes? What kind of event is G?
Merging event.
So what?
Merge.
A merge event. Then what event is this from B to D and E?
That's burst.
It's a burst event, correct. So we're told that after E, F, and G, we have H. Okay, that is the H there. Next, what are we told? After H, we have what?
I.
After H, we have I. So there's no space here. I'd have on this side. We have what? I. Huh? Then we're also told that after I, we have what?
J.
J. So this is the network diagram. Okay. This is how we draw the network diagram. So I just want to see whether we are good with the drawing of the network diagram. So can somebody help let us understand this, because just the drawing itself has its own marks. So here, let's look at this diagram here. Does anyone, I want all of you to participate. Don't mind the description. I want us to come up with a network. So I will crop this, but I have network by you. That's the first thing. Before we understand critical paths, we need to really understand our way of drawing. So especially the ladies who are quiet, we have the events here. So the activity and the predecessor. So where are we starting from?
Starting from A.
From A.
From A, correct. So we're going to draw our A here. All right, A. So after A, what comes? After A,
C.
we have C. So we draw a C there. Okay. Again, after A, what comes?
D.
D. So we have what? D. All right. Again, after A, what comes?
E.
E. We have E. All right. Then what else are we taught? After E, what comes?
F.
F. So after E, we have F. So we draw it like that. Correct? Then after D and F, what comes?
G.
Pardon? After D and F?
G.
G. So after D and F, these ones are going to give us what?
No mage.
Your mage, correct. That is G. After B, C, and D, B, okay. After B, C, and
H.
after B and C, what we have? So where's our B,
H.
first of all?
H.
All right.
Oh, we don't have a
We
B.
don't have a B there.
So where are we going to put a B? Because B has no what? No
Predecessor.
No
precedent.
predecessor.
So it is alone,
Okay.
right? So
Mm.
after B and C, what we have?
H.
So if you want, you can put B here. It has no starting point. The B and C, we have what? H. So this and that, we have that. Then after G and H, what we have?
I.
So after G and H, we have I. This is also a what? A mage. All right. So this is how the network will look like. Are we together?
Yes.
All right. Anyone behind on drawing the networks? All right. So now what follows is now calculating our missing values. So we have a formula that we often use when we are calculating what we call the expected time. So there's what we call expected time. So average expected time is given by the following variables here. So there's optimistic time, pessimistic time, and we also have the what? The most likely time. So it is given by TO plus 4TM plus then TP. These are just initials. Sometimes you can use slightly, but it's the same thing. So O stands for what? Optimistic time. ML, most likely. P is pessimistic time, then over the variable 6. This is what is going to give us what we call the expected time. Are we together? So if we're going to go to our assignment, it was simply asking us to find the missing values using that formula. So I'll do a few, then I'll ask you to help me. It's just subject of formula here. All right. And if shupile sana, we'll just be using subject of the formula. So let me do an extract of the question to understand where they were coming from. Other answers were already there. Just needed to know the formula. So the expected time, who can remind us what is the formula?
TE.
Okay. So our TE, which is expected time, is got what?
Equals to TO.
Optimistic time, yes.
T plus 4 TM.
Okay. 4 ml, okay.
TP.
Plus what?
Is it TP?
Exactly. Over what?
6.
6, right? We have very good photographic memory. Yes, time in optimism plus 4 time, which is most likely, plus time, which is what? Pessimistic. All this is about time. Everything divided by 6, the same thing. Are we together? So here, it's just an issue of filling in the blanks. So here, what is our time optimistic? It is 2. So we're going to put what? 2 there. Plus 4 ml time, most likely. We have a 3 there. So we're going to put a 3. Then we have time pessimistic. So what is our time pessimistic here? 4. We're going to have 4 there. Everything divided by 6. All right. So when we compute that, what are we going to get? 2 plus 12 plus 4 divided by 6. What are you getting? 3. Isn't it?
Yes.
So here we're going to get the value of 3. Now here, they've given us our expected time. They're asking us to find the pessimistic time. Who can lead us? What's the formula? So we have what? Time expected is equal to what?
O plus 4 ml P over 6.
Okay, so what are we given? We're given 3 things. Number 1, we're
Time
given
expected.
O is 1, M is 2, and expected is 2. So O is what? 1. ML is what?
2.
P, we don't know. And time expected is also 2. Can somebody lead us? Substitute formula. What do we do? So where there's time expected, what do we put?
2.
2, correct? O, we put what? 1.
1.
1.
And O ML,
4 times 2.
2. And P, we don't know.
No.
Divided by 6. So cross multiply this by that. It's 12, right? 1 plus 8 plus P. So all these will go this side. So we're going to have 12 minus what? 1 minus what? 8 is equal to P. All right. So when we calculate that, what are we going to get?
It's close to 3.
3.
So P is equal to 3. So this is a 3. Okay. So this is a 3 that we find. So in the diagrams, I was showing where the missing figures were. So here we found 3. We're just shading them so that you know where they're coming from. Here we found another 3. All right, together?
Yes.
Are we following? So I want somebody to lead us in the next one. Here we're given what? So here we found 3. Here we're given O is what? 1.
1.
TM we don't have. P is 4. And TE is what? 2.2. So 1 dash 4 2.2. 1 dash 4 2.2. 1 dash, we have what? 4. and
and
2.2.
2.2.
This was our O. Then this was our what?
ml.
ML. Then this was our what? P.
P.
This is our TE. I want a lady to take us through. Yes, who wants to try? Wants to try?
Go ahead, TE.
Okay, so we have what? The formula TE is got what?
O
Hmm?
plus 4ml plus P over 6.
Okay, so what is our O?
1,
Our TE is what? 2.2.
2.2.
Our O is 1.
1 plus 4 times, that's the one that we are looking for, plus 4, which is our P over 6.
So cross multiply, right?
Yes.
So 2.2, what do we get?
13.2.
13.2. And this is 5 plus 4 ml. Then what do we do?
Move the like terms together. 13.2 minus 5 is equals to 4 ml.
Yes, then what do we have? 8.2 is equal to 4 ml. So how do we find ml?
Divide by 4 both sides.
Divide by 4 both sides. What is our ml?
2.50.
2 point what?
05.
0.05.
Okay, so is that what we found? Yes, 2.05.
So now, on that one, I was rounding it to a convenient figure, so please I'll have to redo it.
Yes, you can alter it so that that is just mathematics there. Okay. All right, so we get the logic, isn't it?
Yes.
Unless there's anyone behind, wherever we go, it's just subject of a formula. Maybe the last one, since this one is it's the diagonal, the complete diagonal. So here we have dash TM TP TE, so 5 6 5. So dash 5 6 5. I want a gentleman now to lead us. Dash 5 6 5. This was our what?
TE.
This was our O. Then ML, then P, then TE. Yes. Anyone who hasn't spoken, especially on the guys, how do we go about that? Formula. Any gentleman, please?
Okay, TE is equal to O plus 4 ml plus P over 6. So TE is 5. Then O, we are looking for O, and then 4 times 5.
So we're looking for O, okay. It's not 0, so 4 times 5, yes.
And plus 6 divided by 6.
6 divided by 6. Okay. So cross multiply. So this is 30. It's got to. This is O, not a 0. Then
20 plus 6.
20 plus 6.
Divided by 6.
Divided by 6. We've already divided, cross multiplied.
Oh, okay.
And our O remain this side. So here we're going to have what? 30 minus what? 26, right?
Yes.
So what becomes our O?
4.
4 is equal to our O. So this is how we find the figures. So let's confirm. Did we find 4? Yes. So this whole scenario is about what? Calculating. Anyone behind so far in getting these missing figures? We are all together. Now we need to calculate our what? Our critical paths. So can somebody, let's remember how this was done. All right. So now we want to calculate. We already drew our what? Our diagram. We can redraw it maybe for the sake of emphasizing our and those ones that could have missed it. So we're going to redraw the network. Then we put these figures. We're only interested in the time now, that we calculate the time taken. So we only take note of these last column in the network. Are we together?
Yes.
Have I left anyone behind?
No, we are together.
Okay, so I now need us to.
I'm a bit behind, but it's okay. I'll listen to the video, Mr. Collins.
Okay. So now we want to fill in the missing. So I need us to help remind each other how we do the network. So we were given the following network to draw. Okay. So we need to draw this network. We're given that our starting point is what? Is A, right? So how do we draw? Who remembers how we draw?
So
we are
start from
starting
the
at
initial
A.
point.
Our starting point is A. Okay, so we have our A here. Okay, yes. So from after A, we have what?
We'll go to B.
We have B. Then after A again, we go to where?
C.
C.
To C.
All right. Then after B, we go to
D.
D. That is after B. Then after B again, we go to
E.
after B, we go to E. Then after this is a B. After C, we go to what?
F.
F.
So after B, we go to E. Then we're told after C, we go to F. So we have F there. Then after D, we go to
G.
G. So D, we go to what? G. Then after E, F, and G, we go where?
H.
E, F, G, we go to H. So E, F, G, we go to H. So E, F, and G, we go to H. Then After H,
What's I?
Will be I.
and after I,
J.
J.
J. Oh, great. Then you remember. Then we already found the missing values. So quickly, the missing values were what? 3, 2, 2.2. All right. So we have 3, 2, 2.2. Then we have 5, 4, 3. 5, 4, 3. And we have what? 2.2, 4.167. 2.2, 4.167. So 2.2, 4.167. Then finally, what do we have? 4 and 1.5. 4 and 1.5. So let's identify the paths that we have to reach the end. Okay, let's identify. We have the first one. Which one is what? A.
Oh, A, B,
Uh-huh.
D,
Uh-huh.
G,
Uh-huh.
H, I, J.
I, J. So another person to give us.
So we also have A, B,
Mm-hmm.
E, H, I, J.
I, J. Next. Uh-huh. Next one.
A, C, F,
A, C, F. Mm-hmm.
H, I, J.
H, I, J. And now let's fuse in our figures now. So here we have what? So the figures, these ones are the time taken that we now need to fuse in. Okay. We need to fuse in those ones. So our first figure was what? That's 3. Then we have what? At A we have 3. Then B we have what? 2. D we have what?
5.
5. G we have what?
2.2.
G we have 2.2. And H we have what? We're looking at this column. H we have what?
4.167.
4.167. And G we have what? That's J. J we have what?
I. You've skipped I.
Oh, I, yeah. I we have what?
4. 4.
4. And J we have what?
1.5.
1.5. So we add all these 3 plus 2 plus 5 plus 2.2 plus 4.167 plus 4 plus 1.5. So when you add all this, we're going to get 17.9. So critical path is the longest period. Then we go to the next one here, A. At A, we still have the same 3. At B, at 2. E, we don't have it here. So let's check E. Identify E. What is E?
4.
4. 4. H. H is what?
4.167.
Yes. 4.167. Okay. I is 4.
4.
And J is what?
1.5.
1.5. Okay. So when we add this, what are you getting? So 3 plus 2, then plus 3 plus 2 plus 4 plus 4.167 plus 4 plus 1.5. What are we getting? So A, B, E, H, I, J. We get 18.7. And finally, we have A, C, F, H, I, J. A is what? 3. Our C. What is our C? What is our C? 2.2. Our F. What is our F?
What? Nilipa class
3.
swap.
What is our F?
Yeah.
3.
3.
Okay, well.
So 3.
All right.
And H, where did an H somewhere? Our H was what? 4.167. Our I, already had an I. Our I was what? 4. I was 4. And our J was what? 1.5. When you add all this, you're going to have, this is A, C, our A, B, D, G, H, I, J was actually 21.9. Okay, then this one is one that is 17.9. Okay, I need you to get the concept. So after getting the networks, I try to differentiate most of your diagrams. So when you add them, we're getting these figures here. So the critical path is simply the longest duration. So you identify which one has the longest duration. It is path 2. So our path 2, which took about 21.9 weeks, is what we call our critical path. Okay, any questions at this point?
Sorry, Collins, on the PET diagram, we don't need to indicate the times.
Not necessarily. This is a PET diagram network. All right.
Okay.
Yes. But if you went ahead to put times, you will not be penalized. Still okay. For other documents, I was putting time, but this is
Okay.
okay. Any other questions? So what is a critical path? It is the longest sequence of the activities, just from the start to the finished. The start to the finish, the longest sequence of activities from the start of a project to the finish that must be completed to ensure that the project is finished by a certain time. That is what we call a critical path. An example could be when you're making an omelette, if you want. So heating the pan until it is ready. So we have found this. So the disadvantage with using this type of a chart is that it can take a long time to create one. And this can be a concern for a more complicated project, as well as bigger projects, because they will take longer to accomplish than the small scale activities to do. So a Gantt chart is more quicker and overly complex and difficult to understand due to the sheer number of moving parts that are involved in large projects. So this was in answering the question regarding at C, where you're asked to explain the limitation of a Gantt chart of the planning tool. Okay, I hope we're all at par. Then we go to a last question where we're given activities. So we are told that there's an IT department at the Bank of Zambia and has the following activities.
Colin, sorry to take you back. So our final answer is supposed to be in weeks, just like that?
Yes. Final answer is what? The critical path is simply 21.9 weeks. Yes. Okay, so we want to now come up with what is called a Gantt chart. Now, Saturday and Sunday, we are told is not supposed to be what? Considered. So we are given the time the installer takes at the Bank of Zambia to finally set up and hand over the project. So 1 week will take them in week 1. So we firstly need to find the missing weeks there. So this was special paper 2. In short, it was interesting. It was simply special paper 2 where we needed to come up with a Gantt chart. So we are told as follows, that it took how many days? 5 working days to design a system on the computer. I wish I could start this whole process again, but we understand this one was delicate. We had a number of answers that came through. So I want to just illustrate it. We go step by step. We're told 5 days. So if you're going to count the activity of system design, it is 5 days. So from here up to here, how many days? We're talking about 5 days. So I was using green here. So shaded wrongly here. This one is not activity. So here. So designing is 5 days. So 1, 2, 3, 4, 5. All right. Then we ignore the weekend. It's Saturday and Sunday.
You can't see where you are pressing, sir.
I was about to ask the same thing.
Sorry. Are you able to see now?
Yes.
So designing a computer takes how many 5 days? So this is in week 1. So 1, 2, 3, 4, 5. All right. Then we ignore the weekends. So we don't continue. These ones are dummy periods. Then we're told that to purchase a component will require how many? 3 days. So ideally we're supposed to start here, but we say don't count the weekend. So tuarambira 1, 2, 3. So here we're interested in which week is this? It's happening in week what? Week 2. Together. So here we put week 2. So this is week 2. So 3 days. So we usually consider the week when it started. Even if it's an overlapping, if it went up to there, we still put week 2 there because it started in week 2. That's where the 2 is. So 3 days. Then configuring the computer, how many days does it take? 2 days. So configuring the computer, what was happening? The coloring. This coloring is supposed to be in here because it is purchasing of what component? Okay. So purchasing of component, it is supposed to be there. So those of you, that's why it was important to go through this so they understand. Then the next activity was what? Configuring the network. So configuring the network, it's here. How many days was it supposed to do? 2 days. So 2 days. So that is how the 2 days are. Are we following? So the 2 days for configuring are 1, 2. So they're happening in which week? It's still in week 2. So we're going to put 2 there.
So Collins, how do you what makes you determine the weeks?
Where it's
Considering
starting
that-
from? We're starting from. There's week 1. Each week has 7 days. So week 1, like 7 days. Okay. This is Sunday. This is Saturday and Sunday. All right.
I just, Collins, I think as a follow-up to that question, like this question, they said that it's like it started on the 8th, and the 8th was a Friday. You don't need to consider that.
Yes. That was my question as well.
Okay, let's go to the question. Interesting. Okay, so the question was, okay, so given this, it started on the 8th. Okay, but 8th can be on a Monday. It was not given. So
what we're doing there, Collins, we literally went to the date.
Actual calendar, yeah. So let's go to the actual calendar. So when we go to the actual calendar, which was 8th of what?
April.
8th of April. So let's go to April. Interesting. All right, 8th of April. So 8th of April, according to my calendar, is showing me, I was trying to beam the calendar here. It can't beam, so let me just use it here. All right, 8th of April was on a Friday. All right, so we need to use this. So let me just beam it somewhere here. August 2022 calendar. Okay. 8th was on a what?
Friday.
It was a Friday.
It was on a Friday.
But why is this calendar misleading me? Oh, April, not August, right?
Yes.
April. Okay, so we do this. Oh, okay, so we do this. Interesting. So it's good to discuss, huh? So we get this. Copy. Here we go to the actual work here. So I will document was I working on? Okay. This document. So we'll go on to this document. These are your marks, and don't rush. So it was on a Friday. So we need to redo this. So meaning starting from the 8th here. Unfortunately, or fortunately, it takes us back to the same what? The same timeline. Okay, 8th was on a Friday. So if it was on a Friday is day what? Day what? Friday was day what? It was on a Friday. So we can say this is Friday, this is here. So the calendar is starting from here. All right. So we need to start from here. So let's start afresh. Okay. Thank you for that. So let's start afresh. So the activity should start from here. So we're going to talk about how many days? 5 days. So day 1, put it here. Day 2, put it here. Day 3, here. Day 4, here. Day 5, here. Are we agreeing?
Yes.
Are we agreeing to this?
No, not quite.
No.
Where's they're not quite coming from?
Yeah, because the activity should start on 8th April, which is a Friday.
So we're assuming this is...
So maybe even in the way we are aligning the calendar there, we need to change. Maybe those from 1st to 4th, we can delete them. Maybe we start on Friday.
So we can call
which
this
is going to be a 5th. Yeah.
So
yeah,
we
we
said
need to
this
redo
is
that.
day 1, okay? So we're going to start like this. Is this okay?
No, I think on the first there where you've put 1, I think you have to put 8.
But
I think Collins, just help us clarify. Are we actually supposed to take into consideration of the actual dates? Because there is, so if I say this project is going to take 20 days, it doesn't necessarily mean that my counting can begin on the day
exactly
on the
that
day
is
the
just
project
day 1. Yes, it doesn't mean
that's
that
what I'm
is,
trying
yes,
to clarify.
Exactly. Thank you for that. So this is just day 1. We don't mean that we should write at the 8th. No. It's day 1 of the project. Okay. Did you get his consent?
Yes.
I got him, but is it still wrong to write the actual date?
No, if you want to
when
use
you can
a
figure
calendar,
it out.
This is the 8th. If you want, you can use a double actual calendar. The 8th, the 9th, 10th, for the sake of 12, 13, 14, 15, if you like. Okay, so that you want to know actual date on the calendar. 16th, that's what you want. 17th, 18th, 19th, 20th, 21, 22, 23, 24, 25, 26, 27, 28, 29, the 30th. Okay, so this is April, the actual calendar. That better, but this is day 1. They ask you how long will it take. So if it falls on the 26th, it doesn't mean it took 26 days. This is day 1. Are we together?
Yes.
All right. So we're modifying this using both views. Okay. Then here we can just call this day number. We proceed. So the next activity for this, therefore, 1, 2, 3, 4, 5. So this means that this was happening in what? Week 1, although it was still overlapping to the second week. Then the next activity was what? Purchasing of components. How many days? 3 days. Okay, you can use different color. 1, 2, 3. So in which week was this? Week 2. All right. Are we together?
Okay, on that one, maybe
Yes.
is it wrong to, because it involves, you know, like the first activity there, it's involving 2 weeks. So now, isn't it okay to write first week and second week?
No. You've given us a pattern. You just consider the week it's starting, unless they told us in the preamble to say 1/2, meaning you're including both of them.
Okay.
So the same pattern is what we follow. Are we together?
All right.
Okay, then we proceed. Proceed.
I have a question. So on the days, we're not just supposed to count 5 days, but we're supposed to relate it to the actual calendar. Because when I count 5 days from the 8th, we'll land at 13th. So are we supposed to follow the actual calendar that we are using, or we're just supposed to use the dates to demonstrate and then you come up with the 5 days activity?
So the 5 days, to start with, the top part is the actual calendar of the progression. So on the 8th, then we didn't do anything on a Saturday and Sunday. The next day, which was day 2. So what you're asking is, we put a 2 there or what?
Okay, so my question is, because the way you've aligned it, it's the way it is even on the actual calendar, because
yes.
the 8th is starting on a Friday. So now my question is, are we supposed to follow the actual calendar, or we are just supposed to demonstrate to show the days, to say from 5 working days is, we assume
I get you.
Monday. Yes, we assume 8th is a Monday, and then it's ending on a Friday. So meaning it will end on the 13th. Or are we supposed to relate it to the actual?
We've integrated
calendar?
both thoughts. We don't necessarily need to impute the actual calendar. That's why I'm saying the 8th was the actual calendar, but what we're looking at is day 1, day 2. This is the main theme here. So day 1 was on a Friday, day 2 on a Saturday, day 3 on a Sunday, day 4 on a Monday, day 5, 6, 7, 8. So we're using a parallel approach. This is a calendar. We don't need this specifically, unless we want to be asked on what actual date did we actually finish. So there was a lady who was saying, others that put a calendar. It's not a problem, but day 1 is actually on a Friday. This is what we are following. Have I answered your question?
Yes, but my issue comes in, if we are going to use it for demonstration, I believe if you count 5 days from 8, the next week should start then on the 13th.
Why the 14th?
My understanding is that you're supposed to include the 8th as well.
Yes, the 8th, yes. 8th.
So that's supposed to be day 1. Because you so if you count 8, 9, 10, 11, 12, meaning the next week will start on the 13th, not so?
So 1, 2, 3, 4, 5. So on the 12th, is that what you're saying? When you count here, it's 1, 2, 3, 4, 5. So on the 12th?
That week ends. Then the next week starts on the 13th.
All right, I get you.
So I'm thinking Cleopatra is adding the weekends, right?
Exactly.
No, I'm not adding the weekends.
Hello.
This is why.
This
is why in the first place I asked to say, are we considering the dates just to demonstrate?
Yes.
Or we are supposed to bring it to reality where I count 5 days, let's say 8, 9, 10, 11, 12. Then I exclude the weekends, let's say 12, 13, 14. Then my next week will start on the 15th. Is that how it's supposed to be done?
Yes, that's what we are doing. Yes. That's how it's supposed to be done. We're supposed to end here. Since we excluded 2 days, we just added the 2. That's why we're starting. The next event is starting on the 15th.
I think I hear her point.
Okay.
So her point is simply her point is what we are doing in a different way. Yes. So it is 8. So 1, 2, 3, 4, 5 on the 12th. That's where. But since we included the weekend, we just add 2 more boxes. 1, 2. That's why we added these ones here. It's one and the same thing that we are doing here. Then we start the next event here on day 8.
Now, hi.
Yes.
Now so on the 15th and the 18th, that was Easter period. So how do you treat that? 15th of April, 16th, 17th, and 18th was Easter period. Okay, so you have to consider it in this.
Was there an exception? Was there an exception for holiday? It was just weekend, isn't it? I think in his email.
Yeah, I think the doc actually clarified on that one. He said consider that there were no holidays, only weekends.
Weekends, yeah.
Yeah.
Consider only weekends, yes.
So meaning when drawing the graphs or the gantt, meaning the next one will start on the 15th, right?
Yes, on the 15th, that's what we're starting. The next one on the 15th. Okay. Are we clarified on that?
I think Cleopatra's questions has raised another concern with me here. Like there where we are saying day 1, which was a Friday, then Saturday, Sunday, which we are including to say day 2, day 3. I thought those days we are counting the actual days that we're doing those activities. So why not put under the date on 11th April, under there we say 2.
It'll be because the number of working days is as good as adding them here. Okay, there'll be no logic there. This is part of the project run. Even if there's nothing that is happening there, we're asking in how many days the project going to be done. Okay, in 39 days or 40 days. Although nothing is happening here, they're still part of the project run. We can't avoid them. All right?
Okay, thanks.
Any other question? Raise very important concerns which are very valid and good. All right, so we have concluded. So week 1, designing of the computer, 5 days. Then purchasing of components, 3 days. So 1, 2, 3. This is happening in week what? Week 2. Then we go to configure network. Network configuration is starting for how many days? 2 days. So it will start here. We're going to say 1 and what? 2. So this one is starting week 3. So put 3 there. Okay. Then software design.
Mr. Collins.
Yes, sir.
Where you've put a 3, is it the right place?
This one is starting in week 3. The green, which is what? Configuring network. It's in week 3. Which week is it starting?
Oh, okay.
Yes. Even if it was overlap, we're looking at where it's starting. Then prepare software, it is where? How many days? 2 days. So 2 days. So we have what? 1 and 2. But it's starting in week what? In week 3. So we're going to put a 3 there. Next person to proceed. Install software. Install software, how many days? 4 days. All right, so we're starting here, install software. So let me finish the numbering here. So 30, April ends where? April ends on the 30th, right? So meaning here we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th. And here the projection still goes 24, 25, 26, 27, 27, 29, 30, day 30, day 31, day 32, day 33, day 34, day 35, day 36. All right, so I'm just adjusting the timeline, but I didn't omit anything. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, and 38. 7 and 38. Okay. So the activity that follows now that we're considering was what? After the blue was, so we started with the red, which was to purchase components. Then we went to the yellow, which was to configure to purchase components. It's the yellow. Then the green, which was to configure network. Then the blue to do what? To prepare software. When we go to purple was to do what? To install. So installation was taking 4 days. So 4 days, we go here, 1, 2, 3, and 4. So this was happening in which week? Week 4. So we can put week 4 there. 4 days in week 4. Next activity was assemble computers, 7 days. And give it red. Assemble computers, 7 days. So you can grab these ones here. Assemble computers, we'll start from here. So let's check assembling of computers here. How many days? 7 days. So we're going to 1, 2, 3, 4, 5, 6, and 7. Okay. These ones will be deleted. 7. So this is starting in week 5. So week 5, we put it here. Week 5, I'll put it in black because of the color. So week 5, let me put them in black, all of them. Then the next one will be pilot test and refine the system. Now connect computers 3 days. So connecting the computers 3 days. So 3 days, we'll put it in yellow. So in yellow, 3 days, 1, 2, and 3. Okay. So this is her starting in what week? Let's check what is the week here. Week 6. Week 6. 3 days. So we go here. Connecting the computers. 3 days. Any questions at this point? Anyone who's lost? Are we together?
Yes, what?
All right. Then pilot test and refine system. How many days? 2 days. 2 days. So pilot and refine system 2 days. So this is a weekend. We will insert to the right, to the right again. To the right again. Okay, these ones must be in what color? Colorless. Okay. So we're taught that we need to do what? This is already done. It was in yellow. Then this one, pilot test, we can use blue. How many days? 2 days. So 2 days will be 1 and 2. And finally, we are told we will set up. So this pilot test, in what week is it? So this was week what? Week 7. Week 7. So week 7, that is where we're doing the pilot test. Then 1 day, handing over the project. So when we go here, 1 day, we've been handing over the project. We'll put color what? Color purple. So handing over the project 1 day. So handing over the project 1 day. So this is 1 day. That is still week 7. Color purple. So handing over the project. So 7, 38, 39, 40, and 41. I was turning to 41 days. Any questions so far on what we've done?
Collins. I'm still there on connecting. Is it connecting computers? Just down there, it shows week 3 for 3 days.
Connecting computers here. It's supposed to be week
But
what?
I've noticed here this.
So 3 days yellow, connecting computers. Thank you for that. So connecting computers is here. This cannot be 3 day, week 3. Connecting computers is in yellow. So this is week what? Week 5. And this is supposed to be week 6. So week 5. So connecting computers week 5. This is week 6 and 6 here. Thank you for that. Okay, any other content? So, like was said, the calendar. Yes, please.
Yes,
yes.
So, okay, now this where does how do we what I want to check is I've lost your for some reason. Okay, yeah, your screen is back. I lost it. So it's ending on when now? When are we going live here? Setting up the last activity, which is activity number 11.
So activity number 11, according to our calendar, is ending on the 41 days. On the
41 days.
Okay, so let's use some logical. Let's add these days. How many are these days going to? 5 plus 3 plus 2 plus 2.
There will be 29.
The number of days?
Yes, there will be 29.
Yes, 29. Now this 29, we're adding how many weekends to actual day number? 29 plus 2 is 31, plus another 2,
yes,
33, plus another 2, 35, plus another 2, 37.
7.
Okay, plus another 2, 39, plus another 2, 41. So it tallies 41. Yes. Oh, this was cumbersome.
It ends on 41.
Yes.
Now
it ends on 41.
Now
day 41.
Now,
but the actual days that we actually were 29. Yeah. So minus 29, which means that we had 12 dummy days. These 12 dummy days were just added because there was nothing happening, but they elongate the project life. Now you can ask.
Okay, now in the question, they said that the project was executed from 8th of April to 20th of May.
Okay.
Does that have does that have an impact because we haven't gone to 20th of May?
So 8th, that is in April.
Yes, 8th of April to 20th of May.
So when you use this calendar here, okay, so
we are not reaching 20th.
Let's see, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is 16, 12, 13, 14, 15, 16, 17, 18. That's a good concern. Where have we lost the 2 days?
So I realized that we lost the 2 days because of the Easter holiday, Monday and Friday.
People can think, okay. Are you hearing that? It makes sense, it adds up. But what did he say in class? That adds up.
We're not adding the Easter holidays.
So we need to create a dummy on the Easter period, isn't it? Yeah, that's the only justification, because that is what will make this complete. And when is the Easter? When was the Easter? On the what?
On the 15th to 18th.
So 15th here to 18th there. So with what he has suggested, permit me to make the adjustment, because that's what will take us to the 20th. Are we all agreeing?
Yeah, I actually agree with him.
Okay, so meaning the blues will come here. All right. So this simply means.
Mr. Collins, please explain why you are adjusting again.
Because the holiday is assumed to not have been, we're not working on the holiday. So there are two reasons why we're adjusting here. Number one, the end period is not what? Is not reaching up to the 20th, because the last calendar here must show us up to the 20th. Okay. So
now it's like the lecture as well. I don't know, because in the question, he says something else, and then in the explanation again, he says something else, because I remember him saying, we shouldn't consider the holidays. We only assume to say this month had no holidays. But now this is again confusion.
Everything must speak to each other, because he made a very significant concern here. So I'm agreeing, unless otherwise we can have maybe before I go there, because I'm just working on the instruction of logically.
I think all the changes the lecturers have been communicating in writing. So to say I heard him say, I don't remember him saying.
You don't remember him saying? Me, it's me who asked him actually during class.
Okay.
So this brings ourselves back to the question, because if these dates were just given as a way of coming up with a scenario, then we would have not ended on the 20th. But it seems like even as he was preparing, it was relating to the actual calendar.
It was. So every bit of what we've just explained here is very important. The actual calendar, which shows us the projection of where it's ending, and the day, which is giving us on which day, day 1, day. So it is actually day 43. Okay. So I'm agreeing. I'm going to, for those ones who got a copy, I'm going to give you 2 copies. You're now going to make your own decision. But if you ask me, the lifespan of a project is already predetermined. There's no way these days would have been put there for no reason. So if we're going to go back to the question itself, okay, this is also a guide saying this is the period. So whether a guide,
and the assignment is due at 10. Wow.
Okay, so I will do 2 Gantt charts. You make your decision, but I agree with him totally. The previous, we can only reach that because we can't account for the 2 days unless we go that way. So I'm going to Just so I'll call this Gantt chart 3A, then I'll go to Gantt chart 3B. So you can even put a note to say these ones were holidays. What were the holidays again? 15th and 18th.
Yes.
Yes.
15 and 18, yes.
So I'm going to highlight these 2 days. Okay. Then I'm going to push the blue, will move here and here, the 2, and I will delete these ones here. Okay, so here we have nothing. There's nothing, there's a holiday here. Then these 4 days, I'll move them. So these 2 will add here. 1, 2, purple. 1, 2. And I'll remove these ones here. Out. And here, these 2 will be added here. The red. Then I'll subtract these 2 here. Right. Then here, these 2, I'll add them here. The yellow. And I'll subtract these 2 here. Then I'll need to add 2 more days, 2 more columns here to the right. Again, another one to the right. So we call this the what? 42 and 43. 43. Okay. I don't like that it's coming. Okay, so where was I? Where was I?
The yellow.
The yellow, so meaning I'm pushing these 2 blue here. Blue 1, blue 2. Then these blue will be normal. Then, so this is 40, 41, 42, 43. It's supposed to end on 40 what? Well, ended at what?
It's supposed to be 43.
19 and what? 20. 20.
So adding more no. Just removing the 2 purple.
Like this, right?
Yes.
All right. So I think this is now what makes sense here. So this calendar is now filled. So I'll call this what? Gantt chart 3B. So these are your CAs you need to modify. Thank you so much. Unless there are any questions, I hope this was helpful.